Hi everyone, my name is Ethan. I'm from Carnegie Mellon University. I'm currently a product designer at Facebook AI. And today I'm going to share the paper I worked with my fellow peers on Wikipedia ORES Explorer, and it's about visualizing trade-offs for designing with machine learning API. So the agenda for our meeting today, I'll go over the challenge in designing with ML API, the ORES Explorer interactive visualization, which is our design visualization. And now I'll talk about the user testing and insights we gathered. And lastly, I'll touch on the generalizability of design as well as future research opportunities. So really quickly about the context, with the growing industry applications of artificial intelligence, we have a lot of AI models that are powering our day-to-day experiences. We also noticed that there are growing and more pre-trained models and APIs, and those APIs and models emerged and greatly lower the barrier of building AI-powered products. So originally, only AI researchers will be able to use AI or those ML engineers to build AI products, and now almost everyone with limited ML knowledge will be able to build products with those pre-trained models. The problems that come with it is that novice AI application designers, defined as both designers and developers who are building AI products, often struggle to recognize the inherent algorithmic trade-offs and evaluate model fairness before making informed design decisions because of the lack of ML expertise in the design process. So for previous work and research gap, we found that there are a lot of work around human-AI interaction design and explainable AI. And those works have also demonstrated a growing need to assist application designers understand trade-offs in ML systems. One particular research gap we have identified is exploring visualization techniques to provide the model trade-off understanding and really validate our design in a real-world context. In this case, we worked with the Wikipedia ORES AI system. So what is ORES? ORES is a web service and API that provides machine learning as a tool to help maintain Wikipedia edits. As you can see, as a simple example, ORES can take in an edit ID and then output a damaging score and a good faith score. Using those scores, the developers or application designers in Wikipedia will be able to build tools to really maintain Wikipedia edits. So this is an ecosystem. As I mentioned, we have application designers or tool developers volunteered in Wikipedia community. They use ORES to build review tools, automated bots, and those bots will directly those tools will directly impact on kind of moderating or maintaining edits on the platform. The problem is that, as I mentioned really quickly in the context slide, application designers in Wikipedia without ML background struggle to efficiently and responsibly build tools with ORES API. The solution we are offering and we designed are a set of visualizations to help application designers to better understand Wikipedia's content moderation models, threshold trade-offs, and fairness so that they can better design tools for the community. We went through an iterative design process, starting with initial research. We interviewed a few Wikipedia stakeholders, as well as doing literature analysis to really understand what are the existing work that's done in this space. And then we go into ideation, generating different ideas that could address the problems that we found in the research. Design prototype, we had our first iteration. After we had our first iteration, went into user tests and evaluation, really understand how people perceive our design and visualization, gathering insights in order to lastly refine our visualization, as well as consolidate the opportunities and insights that we're presenting in this presentation. So going to the solution and the visualization, we named it ORES Explorer. It is an interactive visual playground website for Wikipedia's AI models. So the first page user will see is the About ORES page. It provides basic background information about how ORES works with the necessary ML knowledge. So it talks about what is ORES as well as the false positive, false negatives in the context of Wikipedia, so that people can better understand the context before going into the more in-depth information about thresholds and fairness. So the first one, first interactive visualization we have is Threshold Explorer, and the goal is really to visualize the impact and trade-offs of setting different thresholds. As you can see in this demo, the user will be able to see a slider, and then when the user drag the slider, they can see the difference, the changes in accuracy, false positive rate and false negative rate. And then also from the dot map, they can get a sense of the impact of this threshold that they are selecting. They can also choose a particular data point and really try to understand what are the revisions there, and take a deeper look on the particular edits. The next interactive visualization we have is Threshold Recommender. And instead of letting user to explore by dragging the slider, Recommender will directly recommend threshold based on users' goals and preferences. So as you can see in this demo, the user has 3 options: aggressive model, balanced model, and cautious model, with descriptions and graphics to help them understand what it means. After user choose a model that feels right to them, they can also fine-tune it, as you can see here, and see specific performance of that threshold, and also directly copy the code to use it to build their tool. Lastly, we have Group Disparity Visualizer, and this is not only about thresholds anymore, it's more about, can we visualize the AI model's performance on different groups of editors. So in this case, you can see there are 2 groups. One is newcomer edits and one is experienced edits. So by sliding the threshold, the user can see the different performance the model has on the 2 group of editors. And then on the right side, the user can also compare, say, the accuracy score of the model on newcomer edits versus experienced edits, as well as false positive rate and false negative rate. Going into evaluation improvement, we really wanted to test the effectiveness of the tool and also the generalizability of our design. So we recruited 2 groups. One group is within Wikipedia community. So we have people who are application designers and tool developers who use ORES to build tools. And those people are the direct users that will use the visualization and benefit from the visualization. And on the other hand, we also recruited the second group who are outside Wikipedia. And those people are generally designers in the tech industry and don't have particular Wikipedia domain knowledge. We used a particular think out loud protocol. So we gave the participant a design scenario for them to think about, and then we present them the visualization for them to go through the visualization, interact with the visualization while thinking out loud their thoughts and decision process. The interviews are about 45 minutes each, and then we went through all 4 visualization screens, including the first landing page. The insights are really structured based on 3 questions. The first question is, how does the visualization tool meet our design objectives? And we found that contextualized ML concepts in the About page was really helpful for participants with limited ML expertise to start learning about the ORES API, such as explaining what is false positive in the context of ORES and Wikipedia, and what is false negatives, help them have the initial understanding to learn more about the ORES system. ORES Explorer also improved participants' understanding of the trade-offs, and they perceive the associated impact on setting different trade-offs on the tools they choose to build in the design tasks. Participants were also able to use Threshold Explorer and Recommender to make threshold decisions, and also evaluate those trade-offs that are aligned with their design goals in the beginning. We do find a limitation that although Group Disparity Visualizer helps surface the ORES model's performance disparity in different editor groups, Most participants accepted the disparity as natural occurrence and were not particularly concerned about fairness implication in the system. How does the tool change participant perception around AI systems? So we found that when balancing different performance metrics to select the model threshold, participants tended to really prioritize model accuracy over other metrics. Although accuracy might not be the most important metrics in certain scenarios, because of some participants are not familiar with other metrics, they tend to really emphasize on accuracy when making the decision. Overall, ORES Explorer helped participants to trust the underlying AI systems more. The visualization, because of surfacing AI models limitation and have more transparency in the system, it really allowed participants to see the AI models not as black boxes, but rather as helpful and editable tools. Lastly, we want to assess how can the tool be effective for people less familiar with Wikipedia context or people who are newly to the community. And then it showed that our visualization was effective in helping participants understand the ORES ML system the same way with or without Wikipedia domain background. Generalizability of design and future research opportunities. First, beyond content moderation in Wikipedia, we noticed there are a lot of other high-stake AI use cases, such as criminal sentencing or disease diagnosis. And those use cases are really in need of tools to help application designers and stakeholders to understand model trade-offs and fairness. And stakeholders, for example, including judges or doctors, that will work with the AI systems, they will also have an incentive to understand the trade-offs when setting those different thresholds, and also if the model have any fairness issues. There is opportunity to build on ORES Explorer and create a model-agnostic visualization tool that allows users to visualize model value trade-offs and fairness with custom models and use cases. So in this case, we built ORES Explorer tailored to Wikipedia's ORES model. But if we have a model agnostic visualization, we'll be able to plug in any model, and then it could really systematically improve transparency when designing with ML APIs in different use cases. The present research also points to the need for a broader conversation about how ML novices perceive model fairness and explore more effective visualization approaches. In the future, we could explore ways to build on the transparency provided by our visualization tool with user feedback and control mechanisms that could help improve our models over time and further enhance user trust towards the overall ML system. That's all for our presentation today. Because of the limited time, we didn't include all the discussion points or insights in this presentation. So if you're interested, please refer to the full paper for more details. Thank you.